In our previous video, we delved into clipping and its role in the mixing process. Clipping introduces distortion to an audio signal, while distortion itself merely describes the alteration of a signal's waveform. Though the definition remains broad, we associate distortion in music production with a specific sound rooted in the analog realm. This sound is created by adding harmonics and overtones to a signal, which usually generates a warm, unrich timbre. One of the most powerful and visually impactful tools for achieving this distortion is the wave shaper. To understand the wave shaper, we first need some background knowledge of mathematical functions. A function simply maps one numerical value to another. Consider a function like f of x equals x. When you substitute the number 1 for x, the function translates it to 1. Such functions find representation in graphs, where the x-axis denotes input values, and the y-axis represents the corresponding outputs. For instance, when 1 is placed on the x-axis, it aligns with 1 on the y-axis, showcasing the direct mapping. Another intriguing function is the sine function, which aligns x values with the y-axis to create the familiar wavy curves we often see in our synthesizers. The interesting part now is that we can distort, or alter, this sine wave using another function. We take our initial example and adjust it in a way that any values above 0.5 are capped at 0.5. When we now apply this sort of hard clip function to our sine wave, any values above 0.5 get clipped, essentially distorting the original sine wave. This becomes visually clearer when we overlay the sine and distortion functions. Consequently, if you want to process the signal above and below the zero crossing equally, we would need to define our distortion function symmetrically. Understanding that a distortion function merely maps the input of an audio signal, we automatically understand the principle of the wave shaper. Because the wave shaper gives you the ability to precisely draw this function graph to distort the signal according to your specification. If you haven't noticed before, this graph is also shown in Serum's Distortion Effects panel. For more control, you can apply wave shaping in 2 modes. In symmetric mode, the graph alters your signal above and below the zero crossing equally, while in asymmetric mode, you can independently manipulate values above and below 0. In theory, it's possible to mimic the most common forms of distortion using a wave shaper. However, since the challenge with distortion is predicting how it will alter the timbre ofty sound, the only way to truly learn the effect is to experiment with it extensively. I hope I could help you. Distortion can provide you with very sharp sounds which you might need to attenuate. It's important to have some knowledge about the Fletcher-Munson curves in this context. If you want to learn more, click on this video.